All right, so this is going to be a video about finding solutions of polynomial equations, and it's going to be a little bit more in depth than the last video, but it's going to be the same kind of premise where I'm basically just going to be doing 5 example problems. So we see number 6 right here. It says p of x is equal to x to the 4th minus 3x squared minus 4. And it says I have to find all real and complex solutions for this polynomial and then use these solutions to find the factored form for p of x. So what I'm going to do to actually figure out at least the real solutions for this is I'm going to graph that out. All right, so I'm going to use Desmos to graph this out, and it's going to be x to the 4th minus 3x squared minus 4. Okay, now from here, you'll notice that you should have 4 solutions, but based on this graph, you only have 2, that -2 and +2. So what I'm going to do is I'm going to use long division to basically factor out this problem number 6 here. All right, so it's going to be, so number 6, what I'm going to do is I'm going to take the x to the 4th minus 3x squared minus 4, and I'm going to divide out x plus 2, and then I'm going to divide out x minus 2. So I'll do the plus 2 first. All right, first thing I'm going to do is multiply the x plus 2 by this x cubed here. So you're going to get x to the 4th plus 2x to the 3rd, and then we're going to subtract all this out. So negative, negative, this is going to cancel with this, and you're going to be left with negative 2x cubed minus 3x squared minus 4. Okay, from here, I'm going to multiply that x by 2x squared here, so you're going to get, or negative 2x squared, so you're going to get negative 2x cubed here minus 4x squared. I'm going to subtract this off. Okay, these all become positive. This cancels, and you're left with x squared minus 4. Okay, from here, I'm going to add an x up here, and then you're going to be left with x squared plus 2x. Okay, then we're dividing this out here, or we're subtracting this out here. This will cancel, and you're left with negative 2x minus 4. So then you would put a negative 2 up here, and that would make it with no remainder, which shows that you did it correctly because everything canceled out at the bottom, okay? Which shows that x plus 2 is a factor of this. And now that we have that x to the 3rd minus 2x squared plus x minus 2, what I'm going to do is take that and divide by x minus 2, since that's our other factor. So we have x to the 3rd minus 2x squared plus x minus 2, and we are going to divide this by x minus 2. Okay, so I'm going to do this real quick. Okay, you're left with x minus 2, so we just add a 1 right here, and then you end up with x minus 2, and there's no remainder for this since everything cancels. And then you have that other factor of the x squared plus 1. So far right now, our factors for p of x, if you were going to rewrite it, it would be p of x is equal to x plus 2, x minus 2, and then x squared plus 1. But this x squared plus 1 is quadratic, and it needs to be linear. So what we're going to do is we are going to factor this out, essentially. Okay, so I'm going to do that over here. So if you take x squared plus 1, one way of factoring this is to find the solutions. So that's what I'm going to do. I'm going to subtract 1 to the other side, and you get x squared equals -1. You do the square root of both sides, and you end up with x is equal to plus or minus I. So basically, that means that this part right here is going to factor to x minus I and x minus -I, which just becomes x plus I. Okay, but if you notice now, it is a linear factor. So technically speaking, we have all linear factors for p of x. This is our factored form for this problem. Okay. If you notice, there's 4 linear factors, and the power of the original equation is x to the 4th. So the degree is 4, I should say. So the degree is 4. There should be 4 linear factors, which we have 4 linear factors right here that shows that we are we're done. We found all the factors. Now the next thing we need to do is just find the solutions for this. So the solutions would be for each of these factors would be set them equal to 0. So you're finding the root of every single one of these factors. So your answer should be x is equal to plus or minus 2, and x is equal to plus or minus I. So those would be the solutions right there. Okay, so that's number 6. All right, number 7 is x to the third minus 1. So first thing I'm going to do for that one is actually solve it out, because that one solves pretty easy. And I highly advise solving them out if you can. So this is x cubed minus 1. I'm going to set it equal to 0 and solve this. Okay, so I'm going to add 1 to the other side, and you get x cubed is equal to 1. And then you cube root both sides, and you get x is equal to 1. The problem with this is we technically should have 3 answers based on this degree right here, and we only have 1. So what we need to do is figure out what those 3 answers are by factoring this thing out right here. So that's what we're going to do for this. X to the third minus 1, one of the factors is, based on this, x minus 1. So x minus 1 is a factor for this. So what I'm going to do is divide x to the third minus 1 by x minus 1. So essentially it's going to lead us to a quadratic that we can then factor as well after that to find those other 2 linear factors. So I'm going to do long division on this really quick. And we end up with no remainder because we know that x minus 1 was a factor. So there's no remainder here. So you end up with x squared plus 1, which is quadratic. So there should be 2 other linear factors in this based on that squared right there. So we have 1 factor of x minus 1 so far, and then we have these 2 right here. But what we need to do is actually figure out what those other 2 are. So I'm going to use quadratic formula on that x squared plus x plus 1 to figure out those other factors. So we're going to have x is equal to negative b, which is negative 1, plus or minus the square root of b squared, which is 1 minus 4ac, so 1 minus 4. And this is all divided by 2. Okay, I'm going to simplify this out. This ends up being negative 3 in here. So you're doing the square root of negative 3. So x should be equal to negative 1 plus or minus I times the square root of 3 all over 2. Okay, so we have the other 2 solutions now. So now what we can do is make the factored form for this. Okay, so this x to the third minus 1 is technically equal to, if we factored it out, to be x minus 1 times x minus the positive version of that quadratic root times x minus the negative version, the minus of that quadratic root. And you end up with something like this, the factored form. Okay. Now we already found the solutions, but I'm just going to rewrite them because it does ask for those. So your solutions for this would be x equals 1, and then also x equals negative 1 plus or minus I root 3 all over 2. Okay, so we have the factored form, we have the solution, so we're officially done with that. We have 3 solutions in 3 linear factors, which we should have because it's x to the third minus 1. Okay, now we're going to do number 8. It's x to the third plus 8. And again, we're trying to figure out those solutions and the factored form for it. So number 8, it's g of x is equal to x to the third plus 8. Okay. First thing I'm going to do is actually set this equal to 0 and solve, just so I can find any real roots that there are. So it's going to be x to the third is equal to negative 8. If I subtract 8 from both sides, you do the cube root of both sides, you end up with x is equal to negative 2. So we have 1 solution, but we should have 3. So we're actually going to go through the same process again of figuring out what the other factors are, but by dividing out this factor right here that ties in with the x equals negative 2. So x plus 2 is going to be one of the factors so far. So I'm going to divide out x to the third plus 8. I'm going to divide that by x plus 2. So I'm going to do that real quick. Okay, and based on this, there's not going to be any remainder, which is good because x plus 2 is supposed to be a factor for that. That basically proves it right there. So now we need to figure out what are the other 2 solutions from this x squared minus 2x plus 4. So I'm going to use quadratic formula to figure out those other solutions real quick. So you're going to have x be equal to negative b, which is going to be positive 2, plus or minus the square root of b squared, which is 4, minus 4 times 4 times 1, which is 16. And then we're dividing this all by 2. Okay. Well, this is just negative 12. So I can rewrite this to be x is equal to 2 plus or minus I root 12 all over 2. The square root of 12 can break down because there's a perfect square in there of root 4. So this breaks down to the square root of 4 and the square root of 3. And the square root of 4 is 2. So you're going to end up with 2 plus or minus I times 2 times root 3, all divided by 2. You can divide the top and the bottom by 2 here. So this becomes a 1. This becomes a 1. This becomes a 1. And you're left with 1 plus or minus root 3I for the other two solutions. So now we have negative 2 and those two solutions right there to be our 3 solutions. So now what I'm going to do is just write it in factored form. And how that's going to look is the following. It's going to be x to the third plus 8 is equal to, in factored form, x plus 2, because that's one of our factors right there. So we'll write x plus 2. And then I need to make a linear factor of these solutions right here. So it's going to be x minus 1 plus root 3I times x minus 1 minus root 3I. Okay. So that is the factored form for this one. And the solutions for this would be x is equal to negative 2 and x is equal to 1 plus or minus square root 3 times I. Okay. If you notice there's 3 solutions, there's 3 linear factors, so that kind of shows that we did it right. So let's move on to number 9. All right, so let's consider the polynomial p of x is x to the third plus 4x squared plus 6x minus 36. And we need to graph p of x and find one real zero of the polynomial. Okay, so that's what I'm going to do really quick to find what that real zero of p is. Okay, to do that, I'm going to use Desmos. It's going to say p of x is equal to x to the third plus 4x squared plus 6x minus 36. Okay, and if we zoom out here, you'll notice that there's only one real solution right there at 2. So that means that one of the solutions here is 2. So if you find p of 0, it ends up being equal to 2. So x equals 0 is the one real zero for this. Okay, so that's that first part, number 9. This next part, it says use long division to find the rest of the linear factors. Okay, so we know one of the linear factors, based on the fact that that solution is 2, one of the linear factors is going to be x minus 2. Okay, so what I'm going to do is I'm actually going to take that x minus 2, and I'm going to divide p of x by x minus 2. So it's going to be x to the third plus 4x squared plus 6x minus 6. And I'm going to divide this by x minus 2, because then it's going to get us a quadratic equation that we can, again, use quadratic formula to solve and find the other solutions. So I'm going to do this real quick. You notice a little typo here. This should be a 336, not just a 6. Okay, there we go. Okay, now based on this, you can just do plus 18 here, and it's going to be 18x minus 36. So that's all going to cancel out, so you will not have a remainder for this one. And now you can use quadratic formula to figure out this top part here factored. So it's going to be x is equal to negative b plus or minus the square root of b squared minus 4ac. So that should be 72. And then we're dividing all this by 2. Okay. This part right here is going to cancel to be the negative 36, with the square root of negative 36. Well, that's just going to be 6i. So your final answer for this is going to be x is equal to negative 6 plus or minus 6i all over 2. and you can divide the top and the bottom by 2, so this becomes -3, this becomes 3, and this becomes 1. So you're left with -3 plus or minus 3i. Okay, so that's the other two solutions. So we have x equals 2 as one of the solutions, and x equals -3 plus or minus 3i. And the only thing left to do is then write this in factored form. So that's what I'm going to do now. You should get p of x is equal to x minus 2 times x minus -3 plus 3i and x minus -3 minus 3i. And then all the solutions would be x equals 2 and x equals -3 plus or minus 3i. All right, so that's a video on finding solutions of polynomial equations, basically just 5 example problems. Hopefully that cements the concept a little better for you. If you have any questions about anything in this video, let me know.